Problem 6 now asks us to consider conservation of momentum in 2 dimensions. So here, I should probably draw some cartoons of what is going on. So the father is skating to the right. We'll just decide that. So he's going that way. The mother goes this way. Draw those arrows like that. Because one of the other things that we know is that this angle here is 45 degrees. So those two collide, and they're going to travel off in this direction for a little while until they encounter their child, their daughter, who's over here. And then all of them are going to collide, stick together, and move off that way. So one of the things that makes this problem pretty simple, so we'll say this is mass of the father, 75 kilograms. Come back to that. Let me label these things. Mass of mother is 50 kilograms. Mass of daughter is 30 kilograms. I'll label this V. V initial father is 8.2 meters per second. And then V initial mother is 3.3 meters per second. In this problem, you don't have to write down two equations because momentum is conserved through this entire process because there's no friction anywhere. So, as a thing to make this whole problem much simpler, note that momentum is conserved through the whole process. So I can just write down one collision relating the initial and final momenta. So in the beginning I have, and I'm going to do it, well, two equations because I have to do it in x and in y. So in x, the initial x momentum equals the final x momentum. And that gives me, let's see, the mass of the father times the initial velocity of the father. He's moving in x, plus the x momentum of the mother, the initial mother in x, so cosine of the angle equals their total mass times the final velocity in x. And then in y, I have the same thing. But this term is not present in the y direction because the father is only moving horizontally. So the only y momentum comes from the mother's momentum. Again, they all stick and move together in the end, v final y. So now all that's left is to do the algebra that I've written down. So v final x is mass of father, initial velocity of father, plus mass of mother, initial velocity of mother, cosine theta. That's a terrible line. Divided by the sum of their masses. Putting all of those numbers in. So I'm typing mass of the father is 75 kilograms. Mother is 50 kilograms, so 75 kilograms. Whoops. Sorry, I clicked into the wrong window here. 75 kilograms times 8.2 meters per second plus 50 kilograms times 3.3 meters per second times the cosine of 45 degrees all over. Their total mass I can do in my head, 75 plus 50 plus 30 is 155 kilograms. And the Google machine says that the x component is 4.72 meters per second. We'll do the same thing in y. I'll switch colors here. Final velocity in y is mass of mother, initial velocity of mother, not cosine but sine. Yes, I know they're the same because it's 45 degrees. Sine theta, all divided by the sum of their masses. Putting that into my Google machine. That gives me a final y component of 0.75 meters per second. And notice that the problem asked us to find only the components of their final velocity, which we have now done. So this problem was just two copies of the previous problem, right? Previous problem had one conservation of momentum equation. Now we have two.